In this problem, we've been asked to solve y double prime minus 2y prime minus 2y equals 0. This is a second order linear differential equation with constant coefficients, and it's a homogeneous differential equation. So that means that we can use the characteristic equation approach to come up with our answer. So the corresponding characteristic equation here would be r squared minus 2r minus 2 equals 0. We need to find the roots of that characteristic equation. And unfortunately, it doesn't look like it factors, so we need to use the quadratic formula. So r equals 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 2 all over 2 times 1. And if we take a minute and simplify this, we'll see that it turns out to be 1 plus or minus square root of 3. Alright, so we've come up with two distinct roots of our characteristic equation, and from here we jump to our solution. So the general solution is y equals, we do c1 times e to the, and pick one of our roots, 1 plus square root of 3 times t power plus c2 times e to the 1 minus root 3 times t power. That's the general solution to this differential equation. And it's that straightforward each time, as long as we end up with distinct real roots to the characteristic equation. Alright, so how can this get any harder? Well, we could turn it into an initial value problem. So that's the next one we're going to solve. So we've got y double prime plus 4y prime plus 3y equals 0. And then initial conditions, y of 0 equals 2 and y prime of 0 equals negative 1. We need two initial conditions if we want to be able to solve for the two constants that are going to be part of our problem. Alright, but just as before, we can use the characteristic equation. So r squared plus 4r plus 3 equals 0. That one factors nicely. R plus 3, r plus 1. So this implies that r is either negative 3 or negative 1. Alright, so the general solution is y equals c1 e to the minus 3t plus c2 e to the minus t. And of course, order doesn't matter. It didn't matter that I put the c1 with the e to the minus 3t instead of the c2. Alright, but now we've got two constants that we'd like to be able to solve for. So what do we come up with? Well, notice that y prime will work out to be negative 3c1 e to the minus 3t minus c2 e to the minus t. And we looked at y prime because up here our initial condition involves y prime. So let's try plugging in 0. So at this point, if I do y of 0, I'm going to end up with just c1 plus c2, but the initial condition says that that should work out to be 2. And if we look at y prime of 0, we're going to get negative 3c1 minus c2 equals negative 1. Now we have to solve this system of equations, and once we do, we'll know the value of c1 and c2. Alright, so in this case, it looks like we can eliminate c2 immediately just by adding each half of the equation. So if we add the left half, we're going to get negative 2 c1, and on the right half we get just 1. Aha! So that's enough to reveal that c1 should equal negative 1/2. Alright, now that c1 equals negative 1/2, we can plug that in up here in this equation. So negative 1/2 plus c2 should equal 2, and that will lead us to the conclusion that c2 is 5/2. Aha! So now that we've solved for C1 and C2, we're ready to write our final answer, which I'll squeeze in here. That y equaled negative 1/2 times e to the negative 3t, and then plus 5/2 e to the minus t. So there is our solution of the initial value problem.